Well, hello everyone. We're going to try a little experiment here. We are going to cut up a square, turn it into a rectangle, and see if we see any problems with that, mathematical problems. Sam Loyd was an American maker of puzzles and chess problems who lived from 1841 to 1911, and he came up with this paradox that we're going to study today. Okay, what you're looking at here is a square. I'd like the square to be 8 by 8. So let me emphasize that by saying this side is 8 and the other side is 8. It's a perfect square. Sorry for the handwriting. Now I'm going to put in a couple lines here. I'm going to put a line there. I'm going to put a line there, and I'm going to put a line there. This let me change my pointer again. This line here splits this this length of 8 into a 3 by 5. And this line here splits this into 3 by 5. So just to make sure we know what we're talking about, I'm going to put say a 3 here, 5 here, a 5 here, 3 here, 5 there, and a 3 there. Okay. So what you're looking at right now are two right triangles the size of 8 by 3. And this one is 3 by 8. Two trapezoids that are 5 by 5 by 3, and then the slanty line. And this one is also 5 by 5 by 3. All right, let's go on to the next slide. All right, I added on the right side here a rectangle. I made this rectangle out of the 4 shapes within the square that you see here. Here's that 8 by 3 right triangle, and I placed it right there, 8 by 3. This one was placed there, 8 by 3. I took this trapezoid, I rotated it 9 degrees and placed here with the sides of 5, 5, and 3. I rotated this one and placed it here with the sides of 5, 5, 5, and 3. Let me label some of this. Let me get my pen back. This side here is 8. This side here is 5. This side here is 5. This side here is, well, that's 8. And this side here is 5. Notice that the length of the rectangle is, of course, 13. And the square, of course, is still 8 by 8. 8 by 8. So what's the paragraph? Why is this thing so interesting? Well, the area of the square will be 8 squared, which is 64. The area of the rectangle on the other side, on the other hand, is 13 times 5, which is 65. So by cutting up, I'm going to get my pointer back here. By cutting up this square and arranging it as a rectangle, we gained 1 square unit of area. Say they're inches, 1 square inch of area. So if you did this out of paper, you grew an extra square inch of paper. If you did it out of cloth, you got an extra square inch of cloth. If you broke up a country this way, you could get an extra square area for your country. How does that happen? How did we get an extra square inch of square unit of area into this thing? That's a good question. And I'm leaving that to you to figure out. You might try building this thing yourself on paper, cutting it up and remaking this. You might try to get out the Pythagorean theorem, see how long this is, see how long this is, and comparing it to the diagonal there. A number of ways you can attack this. But I'm going to leave that for you guys, and all I can say is good luck.